In this video, we are going to use the double angle formula to help us to determine the cosine of an angle when we know the cosine of double that angle. So in other words, we're kind of using the double angle formula as a half angle formula, which is kind of interesting. Anytime that you get a question where you are looking for either sine or cos of an angle, and you know the cos of double that angle, you're in business. All you have to do is follow this. If you are looking for the cosine of the smaller angle, of the half angle, then what you can do is write out the double angle formula for cos that only has cosine on the right hand side, sorry. And then once you do that, then what you do is divide every one of these angles by 2. Now, in a previous lesson, we talked about why it is that you can do that. But what happens is you're then able to write cos theta equals 2 cos squared theta over 2 minus 1. At that point, you say theta is equal to pi over 6, and that means theta over 2 is equal to pi over 12. And now you've just opened the door. You have the pi over 12 right here, the cos of pi over 12. You're going to have to do some work to isolate that, but you're going to ultimately be able to get a value for that because we know the value of the cos of pi over 6, which in fact is root 3 over 2. So because we know that, we're going to be able to isolate. Now, just for a moment, pretend this question, instead of asking you for the cos of pi over 12, pretend it had asked you for the sine of pi over 12. If that was the case, then you would still use the cos formula, the double angle formula for cos, but you would use the one that isolates sine theta, that gives the potential to isolate sine theta on the other side. So when you do that, now what you're able to do is you're able to divide both angles by 2. And so you end up with the cos of theta equaling 1 minus 2 sine squared theta over 2. Now we justified why you can do that in a previous lesson. And then what we can do is add 2 sine squared theta to both sides. We get 1 minus cos of theta. And now we have an opportunity, after a little bit more algebra, to isolate the sine of theta over 2. And that's helpful because what we can do is let, again, just like we did in the first scenario I mentioned, if this is what we end up with, we can simply let theta equal pi over 6, which again would mean theta over 2 is equal to pi over 12. And then we'd be able to say that 2 sine squared pi over 12 is equal to 1 minus the cos of pi over 6. We know this value to be root 3 over 2, and now we would be on our way to being able to solve for the sine of pi over 12. We'd have to do a little bit of algebra to isolate it. So that's the procedure here. So again, in short, if you are asked to find the cosine or sine, we'll start with cosine. If you are asked to find the cosine of an angle, and you know the cosine of double that angle, then start off by using the formula, the double angle formula for cos that has cosine alone on the other side. If you are asked to find the sine of an angle when you happen to know the cos of double that angle, then begin your solution by using the double angle formula for cosine that has only sine on the other side. And that's the process that you'll follow. And from there, you just divide both of the angles by 2, and you do some algebra in order to solve. So let's give an example of how you would do that with this question right here. So ignoring everything in red, let's just read the question one more time. This question says we know that cos of pi over 6 is root 3 over 2. Determine the cos of pi over 12. Okay, here we go. So again, we're asked to find the cosine of an angle when we know the cos of double that angle. So we begin by using the double angle formula for cos that only has cos on the right-hand side. Now, something which is kind of cool about this, like I said on the previous slide, is we can now take each of these angles and divide them by 2. In a previous lesson, we justified why we can do that. So if I take this angle of 2 theta and divide it by 2, I get theta. And if I take this angle of theta and divide it by 2, I get theta over 2. And that lets me make that grand statement right there. The cos of theta equals 2 cos squared theta over 2 minus 1. Now we let theta be pi over 6. Let theta be the angle that you know about. So let theta equal pi over 6. And what I mean is we know about pi over 6. It's right there. So we let theta equal pi over 6, which means theta over 2 is half of pi over 6, which is pi over 12. And so we can restate that as the cos of pi over 6 equals 2 cos squared pi over 12 minus 1. Well, this is amazing because we actually know what the cos of pi over 6 equals. It equals root 3 over 2. So now we're going to be able to do a few steps and isolate for the cos of pi over 12. This is awesome. We just have to know algebra. Okay, so that's what we do. We say the square root of 3 over 2 equals 2 cos squared pi over 12 minus 1. And then we add 1 to both sides. Now we take a couple more steps if you want to show your work, just to get a common denominator on 1 and then put it all together in one fraction. Nothing too complicated happening there. So we know that 2 cos squared pi over 12 is equal to the square root of 3 plus 2 all over 2. But remember, we're trying to find out what the cos of pi over 12 is, so we're trying to isolate that. Let's divide both sides by 2. If we divide both sides by 2, then on the left-hand side, we would get a denominator of 4, and on the right-hand side, that 2 would go away. And that's what we have at the top of the next slide. Root 3 plus 2 over 4 equals cos squared pi over 12. Now at this point, we know we're going to have to take a square root because we're trying to find the cos of pi over 12, and we have the cos squared of pi over 12. Obviously, we take a square root, but should we put a plus sign or a minus sign in front? And for this, we think about what quadrant it's in. The angle pi over 12, if you remember, pi is equal to 180 degrees. 180 degrees is equal to 180 degrees over 12 is equal to 15 degrees. Well, 15 degrees is right about there. That's a quadrant 1 angle. So we know the angle pi over 12 is in quadrant 1. Well, the cosine of an angle in quadrant 1 is always going to be positive because it refers to the x-coordinate. So that means I'm going to put a positive sign in front of the square root when I square root both sides. And that's what I showed right here. Okay? Now, you have the square root of a fraction. What you can do in the next step is just put the square root in the numerator and in the denominator. You'll see how we did that there. Instead of one big square root on the whole fraction, we put a big square root in the numerator and a big square root in the denominator. And the square root of 4 actually is equal to 2. So what we end up with is that the cos of pi over 12 is equal to the square root of root 3 plus 2 quantity over 2. Now that's method 1. Method 2 would be using compound angle formulas. Another way of doing this is to say to ourselves, listen, pi over 12, that's the same as 4 pi over 12 minus 3 pi over 12. Well, 4 pi over 12 is the same as pi over 3, and 3 pi over 12 is the same as pi over 4. We actually know values of sine and cos for the angle pi over 3 and for the angle pi over 4. So we can actually re-express the cos of pi over 12 as the cos of pi over 3 minus pi over 4. Well, that means using our formula for the cos of pi over 3 minus pi over 4, we'd get cos of pi over 3 cos of pi over 4 plus sine of pi over 3 sine of pi over 4. and we would simply go through our appropriate steps. 1/2 times root 2 over 2 plus root 3 over 2 times root 2 over 2. We'd end up with root 2 over 4 plus root 6 over 4, and our final answer would be root 2 plus root 6 over 4. And you might be tempted to say to yourself, hey, that's not what we got the last time. But believe it or not, the answer we got using method 2, which is being circled right here, and the answer we got using method 1 are actually equal to each other. Okay, so that's pretty cool. Now, a lot of students say to me, you know what, sir, I prefer method 2. I'm just going to use method 2 from now on. The issue is method 2 doesn't always work every time method 1 works. An example would be if I asked you to tell me what's the sine of 22.5 degrees. If you need to know the sine of 22.5 degrees, there's no way you can make a compound angle formula adding or subtracting to 22.5 degrees using regularly known angles. But you can use this method by just recognizing that the cos of 45 degrees is equal to root 2 over 2, and then being able to say that the cos of theta is equal to 1 minus 2 sine squared theta over 2, and letting theta be 45 degrees, you would be able to go through all of the steps similar to what we just did, and you'd be able to give an answer for the sine of 22.5 degrees that way. So fair warning to those who think I'll just always use method 2. Sometimes method 2 doesn't work. And we'll go through the rest of these slides in a later video.